this video and in the next few videos, I want to start talking about momentum and how we apply it to various forms of motion, ultimately leading up to general planar motion. So when we first start talking about momentum, the first form that I want to look at is momentum in translation. So when we talk about translation, we're taking a generic rigid body and saying that its center of gravity, which we would often call g, is moving with some velocity, v sub g. And because we're trying to stick specifically to translation, we would say that this is the only type of motion that's happening. The center of gravity is moving with some velocity g, but the rigid body itself is not rotating in any way. And as a result, our momentum, as we look at this, is relatively simple. So we've seen before that linear momentum, denoted with a variable L here, is mass times velocity. And again, because the only velocity we have occurring at this time is the velocity of the center of gravity, that's the velocity that we include in that momentum term. Now, we would also, in general with momentum, want to be thinking about angular momentum. Now, of course, because we're talking about pure translation, I can write angular momentum, which is often denoted with the variable h, uppercase h, and I'm using subscript g to denote that I'm talking about rotation about the center of gravity. However, because we're talking about linear translation, the angular momentum is just going to be 0. So nothing too surprising. A body undergoing strictly linear translation has only linear momentum, and I think that is pretty straightforward, hopefully. All right, thank you.